Hi friends, this video is going to be about factored form, which is sometimes also called intercept form. And the general rule for factored form is f of x is equal to a, some stretch or dilation value, times the two factors of a quadratic. So x minus r being the first root or x-intercept, and x minus s being the second root or y-intercept. Just like in standard form or vertex form, this a value is the stretch value for the parabola. And so it will tell you if it's positive that it opens up, if it's negative that it opens down, and the value, the numerical value, will tell you what its dilation is, if it's going to be stretched more narrow vertically or if it's going to be smooshed out. That's the official term, to be more bowl-like. We can use these facts of vertex form particularly well for finding the roots. So remember that when you're solving a quadratic equation, you can solve it by factoring it and setting each factor equal to 0. And because it's already factored, it means it's pretty much 90% way of the way through to being solved. So we just can set each of these factors equal to 0, because y would be 0 here, and then we can just evaluate and find the value. So here x would be -2, and on this side it would be +3. And hopefully you'll notice that it's, as long as the coefficient of x is 1, we're just switching the sign for these roots. So that means that we can very easily find 2 points of this parabola. We have the point -2, 0. So these are where y is equal to 0. And the root 3, 0. Okay. Now, that's lovely because we know it's going to go through the x-intercept at 2 points, but we're going to need to do a little bit more work to find where the vertex is and the axis of symmetry is. So let's go ahead and take a look at that. So if I look at this first example, I'm going to find my roots or my x-intercepts by setting this equation equal to 0 and solving. So I already know basically that it's going to be when x minus 5 is equal to 0, I'll have a root, and when x plus 3 is equal to 0, I'll have a root. So I'll have a root at x is +5 and a root at x is -3. So my 2 points then are 5, 0 and -3, 0. So I can go ahead and graph those on my graph. 1, 2, 3, 4, 5. And 1, 2, 3. Just going to put a little mark in here to show that I'm counting by ones. Okay. Now I need to find out where the axis of symmetry is. And one of the great things about parabolas is they're completely symmetrical. So the axis of symmetry has to be halfway in between these two roots. So for a problem like this one, where the roots are relatively close, I can just look at this and I can say, hey, look, there's about 8, well, there's exactly 8 spaces in between these 2 points. So the axis of symmetry must be half of that, or 4 places from either end, 4 units from either end. Oops, let's see if I can get that back where it belongs. There we go. Good thing I put a scale on there. So my axis of symmetry would be here at x equals 1. Now, sometimes these can be further away, so you can also do that by finding the distance, right, between the x coordinates. So for example, I could do 5 minus, because I'm looking for the distance or the difference, 5 minus -3. And then I could take that distance and divide it in half to find where the axis of symmetry would be. So 5 minus -3 would be 8. 8 divided by 2 is 4 spaces, so it's 4 spaces from either root that my axis of symmetry would be. So it's another way to do it. So now I know that these are my roots. I know that this is my parabola, and I know that it's going to open down, but I still don't know exactly where my vertex is. So here's where I need to do a little bit of work. I'm going to need to plug in this x value for the axis of symmetry into the equation and solve for the y value. So I'm going to evaluate this function for f of 1. And I'm going to do that just by replacing the x values with 1. So I have 1 minus 5 times 1 plus 3. And so that will give me negative 4 times positive 4. And so f of 1 is negative 16. So at 1, I'm down 16. Probably don't have exactly enough room. So 1, 2, this is 10, 11, 12. Let's move that. 12, 13, 14, 15, 16. So right here is my, I'll just relabel that for my axis of symmetry. So here's my vertex at 1 comma negative 16. Okay. And now I can just connect those, try to make them nice curves. Oh, this was harder on my board than I expected. So we'll try to connect those into the parabola. Okay. Domain, just to make note, domain, of course, is the set of all real numbers. And the range, here we have a minimum value at negative 16. So we have a minimum at negative 16, and then we go all the way up to infinity going up. I'm going to do one more example, so feel free to pause it, try your hand at this example, and then play it back to see if you've got it figured out. Okay, so first thing I'm going to do is I'm going to find my roots. So I have a root here at x equals negative 1, and I've got a root here at x equals 2. So negative 1, 2. Which means the axis of symmetry must be halfway in between them. So negative 1 minus 2 would be negative 3, negative 3 halves. So from this right-hand one, it would be negative 1.5 down. So my axis of symmetry is at x equals 1/2. I usually find the axis of symmetry from the positive, so I usually subtract the smaller number from the larger number, just for the record. And so I would usually do 2 minus negative 1, or 2 plus 1, and then divide that value by 3. And then I would come from the left-hand side and come up 3 halves. So from negative 1, I'd go 1.5, and that would give me x equals 1/2. Okay. Now, I know that my dilation is negative, so it's going to be a frowny face. It's going to have a maximum value, and that it's a half of the dilation, of the standard dilation. So I know that it would go over 1, up 1 regularly, but here it's going to go over 1, up a half. Okay, or so I could use that to sort of verify where my results are going to go. I could also plot some points just to make sure that I'm being very accurate in terms of where my points are. So I know that I have a x value of 1/2, so I need to find that y value along the axis of symmetry. So I'm going to evaluate this function for 1/2. So f of 1/2 is equal to negative 1/2 times 1/2 plus 1 times 1/2 minus 2. So that's going to be equal to negative 1/2 times 3 halves times 1/2 minus 2 is times negative 3 halves. And so that's going to give me positive 9/8, okay, or 1 and a smidge when I draw the picture in here, okay? I can also plug in some other values that are close by, so maybe I'll plug in 0, just to verify where that would be. So at 0, I would have -1/2 times 1. I'll do this work down here. F of 0 is equal to -1/2 times 0 plus 1 times 0 minus 2, which would be -1/2 times 1 times -2, which is -2 times -1/2, or +1. So here, and then reflecting that over the axis of symmetry at 1, we would also be at 1. So now I've got some points. I can really see where this parabola is going to go, and I can go ahead and graph it. And I can consider that the domain here will be the set of all real numbers, and the range will be a maximum value at 9/8 and a minimum value of -infinity. So, okay. Anyway, I hope that was constructive for you, and thank you very much for your time.